Hello, so we're going to be having a look at constrained optimization, and I guarantee you will come across constrained optimization on your economics degree, whether that be in econometrics or any maths-based economics. You will have to do this, so it's really important that we get an understanding of how it works. So let's have a look at a particular example that I will go through. So we have a function, which I'm just going to put out now for us, and that is x squared plus 4y squared minus 2x plus 8y. And the constraint function is going to be gxy is equal to x plus 2y minus 7. So this is our objective function, and this is the constraint function. So what we're going to do is we're now going to solve this, and we're going to solve it for x and y to find out what the values of x and y actually are. And what we're going to have to use for constraint optimization is a method called the Lagrange Multiplier. Okay, so I'm going to talk through that now, basically to find out what the values of x and y are. So what we're going to do is we're going to combine these two functions together, so including the objective function with the constraint applied to it. So step number 1 is going to be apply constraint. So we've got our x squared plus 4y squared minus 2x plus 8y. Okay, and this is where we include our Lagrange multiplier. We're always going to put a negative lambda. Lambda is this symbol here, so it's negative lambda, and negative lambda is going to multiply our constraint function. So negative lambda, open bracket, x plus 2y minus 7, close bracket. So now we have started the process. So we've applied the constraint and we've used a lambda here, and that's a lambda is this symbol here. Okay, so we've started now. So what we need to do now, our second step, is we are going to derive this function that we've created now with respect to x, then we're going to derive it with respect to y, and then we're going to derive it with respect to lambda. So basically what we're going to come out with is we're going to come out with three answers. Okay, so first of all, derive with respect to x. So if we derive with respect to x, this is just going to be 2x. That's obviously going to be 0, so no need to write anything there. Derive minus 2x with respect to x is going to leave you with minus 2, plus 8y, well, that's going to leave you with 0. Here, we're going to have negative lambda, and that would be 0, and that would be 0. And we can rewrite this formula, making it equal to lambda. So it would be 2x minus 2 is equal to lambda. And that's important because we're going to then put the two lambdas together, and you'll see in a moment. So now if we derive our function with respect to y, again, that would be 0. This would be 8y. That again would be 0. That would be plus 8. Negative lambda x derived by y, well, that's nothing. This here would be negative lambda 2 and again, that would be nothing there at the end. So what we would have here is we would have 8y plus 8 is equal to lambda 2. Okay, and then finally we're going to derive with respect to lambda. So basically we can ignore that because there's no lambda in there at all, so that would be all equal to 0. Then we have we would just have negative x minus minus 2y, and we would have a positive 7 because negative lambda multiplied by negative 7 would give you positive lambda 7. Obviously derived with respect to lambda, you're going to be left with positive 7. Okay, and we can rewrite this formula as x plus 2y is equal to 7. Okay, so we've derived our function by x, we've derived it by y, and we've derived it with respect to lambda. Okay, so next step that we're going to do is we're then going to substitute x and make x and y equal to each other. So what we do here is we're going to put it's going to be 8y plus 8 is equal to 2 open brackets 2x minus 2. And the reason why that is what we've done here is obviously this is equal to lambda is equal to 2x minus 2, and here we see 8y plus 8 is equal to lambda 2. So all we've done is we've subbed in this 2x minus 2 here. Okay, so obviously if we expanded that out, that would be 8y plus 8 is equal to 4x minus 4. Okay, so what we're then going to do, so once we've got this, we're going to rearrange our third equation here. We're going to rearrange x plus 2y minus 7. So rearrange and sub in. So what we're going to do here is we're going to rearrange this and we're just going to make x equal to, so if we've got x plus 2y equals 7, we can just make this x equals 7 minus 2y. Okay, and all we're going to do is we're going to sub this x equals 7 minus 2y into 8y plus 8 is equal to 4x minus 4. So what we would therefore have is we would have 8y plus 8 is equal to 7 minus 2y negative 4. And all we're going to do now is just expand those brackets. So we've got 8y plus 8 is equal to 28 minus 8y minus 4. So if we take 8 to the y's onto one side, we're going to have 16y. So we're going to add 8y to both sides. So we've done that there. Add 8y to both sides. That becomes 0. That becomes 16y. And then we're going to take all the straight numerical values over to the other side. So that would be 28 minus 4 would leave you 24. Take 8 from both sides. So that would be left with 0. And then we said 28 minus 4 minus 8 would leave you with 16. So what we've solved here is we've solved that y is equal to 1, because if we divide both sides by 16, y is equal to 1. So we have solved what y is, which is brilliant. And now all we need to do is we need to solve x. So if I flip over the piece of paper, we're going to sub there's 5 sub y equals 1 into which equation can we? We can sub y into 1 into where we can just sub it into this equation here. Okay, where x plus 2y equals 7. And if we do that, we will have x plus 2 multiplied by 1 is equal to 7. So that would be obviously x plus 2 equals 7. X, take 2 from both sides, x would equal 5. And there we have it. We've solved the values for x and y. So y is equal to 1 and x was equal to 5. Okay, and that's how we use the Lagrange multiplier to solve constrained optimization. So if we just recap what we did there. So we had our objective function here, which was x squared plus 4y squared minus 2x plus 8y, and we had our constraint of x plus 2y minus 7. We apply our constraint to our objective function, and here we use the Lagrange multiplier, and we represent that with the symbol lambda, and we always use a negative lambda. Okay, so x squared plus 4y squared minus 2x plus 8y minus lambda, brackets, open brackets, x plus 2y minus 7, close brackets. Okay, so we've set out our constrained optimization. Then all we need to do is we need to derive this function by x, y, and lambda. If we do that, we get 2x minus 2 minus lambda, 8y plus 8 minus lambda 2, and then we've got minus x minus 2y plus 7. Rearrange those slightly, and we get there. Something to probably note here is obviously when we derive, that would obviously be equal to 0, equal to 0, equal to 0. Okay, so that'd be something you may have wished to include in there. Sorry, I should have probably done that earlier on, but hopefully you're well aware of that when obviously deriving. If you wanted to, obviously, you could have written this formula in full, expanded the brackets here. That may have been something useful that you wanted to have done. Obviously, as you practice over time, obviously a lot easier. You don't need to expand fully, but you may have wished to expand that too. And then it may have helped you with your derivatives, your derivation. Okay, and then all we did here is obviously we saw that lambda is equal to 2x minus 2 and lambda 2 is equal to 8y plus 8. What we would do if we just put these together, we'd have 8y plus 8 equals 2, open brackets 2x minus 2, expanded that, 8y plus 8 equals 4x minus 4. And then what we did was we rearranged and subbed in the derivative here, we found a derivative here with x plus 2y equals 7. We subbed that in, and then by doing so, that found out that y was equal to 1. And then all we needed to do, with knowing that y is equal to 1, we could sub y into this formula here, and that obviously left with us x plus 2 equals 7. Take 2 from both sides, and that left us with x was equal to 5. And therefore, we have solved what the values of x and y are. I hope you found this useful. If you have any questions, then please let me know, and I will send out some more constrained optimization questions for you to have a go at.